So moving into section 3.3, we are going to be looking at probabilities where we are selecting an option from a group of them. So in 3.2, when we were making our selections, we were talking about situations where we wanted this, and this, and this, and this, and this, and we wanted to find out what the probability was of getting all of them where we'd multiply. For this situation, we have multiple options again, but instead of saying, I want to pick all of them, or some number of them, we only want the one. We want to take all of those things and say, well, what's the probability that I get just this one, given all of the other ways it can happen? And to understand this, let's think of a maybe real-world example. So, let's say you get up in the morning, you're a little bit late getting out, you get to campus at a reasonable time, but you didn't have time for breakfast. But you got $5 on you, and you got time to head over to the Union, so you think to yourself, hey, maybe I can get myself, I don't know, a bagel, or a wrap, or some kind of sandwich, or you can hold off and save that $5 for lunch. Well, these choices would be what we call mutually exclusive choices, because they can't happen at the same time. You only got $5. That's maybe enough for a bagel and a trip to the vending machine, but you're not going to be getting a wrap and the bagel, and you're certainly not going to be getting something for breakfast and something for lunch on that money unless you're talking about getting 2 bags of Skittles. So, presumably, you're not going to be able to have all of those things, or even more than one of them, at the same time, and we say that such things are mutually exclusive or disjoint. And while this example here doesn't have any probabilistic value, because I didn't attach probabilities to that, I don't know what probabilities would be tied to your hunger, we can still talk about probabilities in much this same language, where I will say that for events that are not mutually exclusive or not disjoint, unfortunately we don't have a nice way to say that lacks syllables. And no, we don't call them mutually inclusive or joint, unfortunately. We just have to settle for the double negative. But anyway, let's look at a couple of quick examples here to get a sense of what this sounds like. So for this, we want to determine whether the events we have here are mutually exclusive with some explanation, where our options are event A is rolling a 3 on a die and event B is rolling a 4, while for the second case, we have that event A is randomly selecting a male student and event B is randomly selecting a nursing major. Well, thinking about this, for our first case, if we want to talk about rolling a 3 or a 4 on the die, what we can understand is, well, you can't get both on one roll. We're not, importantly, saying roll the die twice and find the probability of getting a 3 then a 4, or a 4 then a 3. We're saying toss it once and see what happens. For the record, I got a 6, but it'd be pretty appropriate if I got a 3. It'd be kind of cool. But the idea here is we're taking one shot, and in this one shot, you can't get a 3-4. You've only got a 3 or a 4. So these events are disjoint. And generally, I'd use disjoint over mutually exclusive for the reason that it's fewer syllables. And, well, I talk enough at you. Any chance I can get to save some vowel sounds is probably appreciated by all. Anyway, for our second case, when we're looking at the nursing majors, well, thinking about this, yes, nursing is a field that is primarily dominated by women. So presumably, nursing colleges would also be largely dominated by women. However, even though it is rare, there are male nursing students. and there are male nurses.
I'm dating a nurse.
Presumably. So, since there are male nursing students, these events are not disjoint. So with the idea of how we can consider these things in terms of being, in a sense, completely separate of each other or not, we'll then talk about how we can see their values in terms of probability. That is, how we can measure the probability of getting one thing or another using what's called the addition rule.